Assalamualaikum and a very good day to the panels. My name is Saiful Firdaus Bin Saiful Nizam and I'm going to present the proposal of the final year project 1 entitled Design of Linear Induction Launcher for Magnetic Levitation System. My supervisor is Dr. Suhana binti Sulaiman. For the content of this proposal presentation includes project summary, introduction, literature review, problem statement, objective, scope and limitation, methodology, and lastly the expected results. The project summary is about the application of magnetic levitation on magnetic levitation trains. The design of the arrangement of magnets for the magnetic levitation is studied in this research. The three forces that required in magnetic levitation system are propulsion, levitation, and guidance. The introduction for this research is the development of trains. The evolution of trains from steam locomotive train to the current developing train, which is the magnetic levitation train. The current testing magnetic levitation train are reaching the speed around 600 km per hour due to the magnetic field that produce. Compared to the typical linear motors with rotary motors and lead screws, the linear motors with mag left mover have no backlash or rotation-induced vibration. Thus, the main advantage of magnetic levitation motors can prevent wear, friction loss, the usage of lubricants, and the generation of wear particles during motion. Continuing with the presentation is the literature review on design of magnets affecting magnetic field of flux. Also, and D. L. Trumper said that in their articles, the use of a small magnetic architecture decreases the number of sensors and actuators required to stabilize the stage levitation. Next, D. L. Trumper again with M. Knorr and W. Gruber said that a permanent magnet on the mover produces an open circuit field that creates the primary magnetic field for force output on the coil side. Lastly, M. Dyke, X. Lu, and Y. Altintas mentioned in their article that Hilbert arrays are used to generate a magnetic field on the underside of the magnetic array with virtually little magnetic field on the top side of the magnetic array. Next, we move on to the problem statement. First, the arrangement of the magnets are the most important task in order to get the greater power of magnetic field or flux. Next, the wrong arrangement of magnets used could cause the magnetic field become weaker or even out of control because of the stronger repulsion from the pole of the magnets. So the problem of this research is to identify which design is the most suitable design to have such high precision, density and strongest magnetic field for the magnetic levitation. Next, the objective of this research. First, to identify the arrangement of magnets will affect the magnetic flux of the magnetic levitation, and the 3D simulation of electromagnetic field based on ANSYS Maxwell that executed to validate the theoretical design. The scope and limitation for this research is to verify the strength of magnetic field to levitate the samples. 4 samples are going to be tested, which 2 standard arrangement and 2 using Hilbert array arrangement. For analyzing the samples tested, we are going to use the ANSYS Maxwell software to get the picture of and the simulation of the electromagnetic field from the magnets. This is my process flow of this research. There are 4 phases, starting with initial study on research, which the literature survey, information gathering of this research, and next is designing the 3D model in ANSYS software or even CAD software, which the designing 3D model of magnets arrangement. The magnets arrangement are standard arrangement and also Hilbert array arrangement. Next, the analyzing data from ANSYS Maxwell. I'm going to input the parameters for magnetic field analysis and conduct the research. Then lastly, for the last phase, analyzing result from the data. In this phase, we are going to get the data management, analysis, and also result, the conclusion of the result. The expected results. The expected results are going to be as shown in this figure. The first one is the 3D model of the Hilbert array arrangement, and this is the Hilbert array magnetic field that shown only one side are stronger than the other. This is the simulation example of simulation of Hilbert array arrangement of the magnetic field that flows for the magnetic field. And lastly, these are the 2D schematic for the Hilbert array arrangement. These are the references for my proposal for final year project 1. There are 14 of them, as you can see, from 1 until 14. Thank you for your time. That is all from me. For any inquiries, you can contact my telephone number, which has WhatsApp, and also my email, my personal email. That is all from me. Thank you very much.